know where there's some. Right here in the hall clerk.
No, Molly, not in there. I have enough.
Okay, I've got our little AC to DC power supply. It's a tiny little thing right here tacked in. It's going to pins 1 and 3, the primary side of the power transformer. And I'll hook up, let's see, I'll hook up this DVM to negative and positive on here. Okay, and I'll turn on the meter and we'll plug this in. And there it is. It's generating the 9 volts we need for the frequency counter / display. So I'll start tacking that in now. Okay, I have the a lead for the I call this a display. It's much more than a display. It's actually a frequency counter, and I should call it that. So the frequency counter, I've got the power supply lead hooked up for the frequency counter. This one won't be, I don't think, quite long enough for the final version, but we'll see. The circuit board for the frequency counter is marked with a sine wave here and a ground here, so that's the signal output. This is the 9 volts in, and now we should be getting 9 volts to this frequency counter. Let me plug it in here, and we'll see what happens. Ta-da! So the frequency counter lights up. I think this digit, let's see. I forget what these buttons are. Oh, yeah, we see it light up. I don't know what all this means, but anyway, it works. Good. So we have power, and now I'll tack the signal into the other end. Okay, I've got a 0.05 microfarad capacitor connected to this side of the RF fine potentiometer. Comes out here, goes to the signal side of the frequency counter. The other side just goes to ground. I've got it clipped to the frame right here. So let me turn this around carefully. Oh, it's upside down. That's okay. The meter's upside down, so low frequencies will start on the A band, which runs from 100 kilohertz up to 300 kilohertz. We'll see what we get with that. So I'll just dangle this right here. No, I'll hold it like that. Let me plug the meter in and we'll see what we've got. Uh, 165, 163, 166. We'll run up the scale. Oh, I don't know how high this has to be. Guess it doesn't matter, actually. 159, 161, 169, 185, 192.7. On the A scale, we're at 100. 50, 40, about 140, run up to 300 on the A scale, and 347 it says. Let's switch to B, which will have the IF frequency I'm interested in. So there's on the 455 mark on the meter, and this says 496. It's drifting around quite a lot. Well, it could be because we're getting too much signal into the counter. What I need to do next is get my oscilloscope out and take a look at the. I think the documentation that came with the frequency counter indicates what the maximum input voltage peak to peak should be. So I'll have to get my oscilloscope out and measure what we're putting into this. We might be overdriving it, which would cause that kind of drifting. So I'll do that next. Right, I've brought my oscilloscope down. It's right here. You can't see it, but I'll move the camera in a bit so you can see the screen. We're still getting the drifting on the display. And I was looking at the documentation. There are two possible reasons. One is insufficient signal, so we'll see if that's the case. It has to be above 60 millivolts or something like that. So we'll see what we're putting into this frequency counter. The other is a pretty clean power supply, so we'll put the scope on the 9 volts out on the power supply, which is right here. Let me see if I can move this all without shocking myself. 9 volt power supply is right here. So we'll put the scope on there and see what that output looks like, whether it has a bunch of ripple on it or not. The third thing is that this signal lead from the potentiometer through our 0.05 cap, this should all be shielded, should be coax, and it's clearly not. It's clearly able to pick up all the radiation from the RF oscillator here, and the tuning capacitors in here. So it's not in the slightest shielded. What I'll do next is, now that we know we're getting signal through here, and it's enough to certainly drive, it appears to drive the frequency counter just fine. Then I'll try it with some shielded coax. But let's take a look at waveforms right now. Let me move the camera. All right, here we are looking at the frequency counter side of that 0.047 actually capacitor, 0.05. The frequency counter is showing us 500 to 515 or so kilohertz, and this is the output on the scope. We're at 0.5. Can I read that? I can't quite read. Yeah, 0.2 volts per division. Turn up the reticule, you might be able to see that. Center line is right there. So we're on AC, DC, and we're getting no DC voltage through, so that's a good thing. We're at 0.2, so from center line, 0.2, 0.26, 0.26 above and below the center line. So that's 520 millivolts peak to peak, which is plenty of signal for the frequency counter. So let's take a look now at let's run it up and down the scale a bit. Yeah, it maintains its amplitude pretty well in this. This is the B scale, this is the 455. Let me go up. Same thing. We're in the, there it's starting to drop a little bit, but this is the FM range in here for IF frequencies, so that's all I care about. Just for giggles, let's go up to the highest frequency. Its amplitude is not much, and the scope can just barely eke it out, as you can see right there. But that's still a pretty good sine wave at 20 megahertz, according to the frequency counter. And it's much, yeah, it's 20.526 there. So that's pretty good. I got no complaints with that. So back to our IF, around our IF frequencies. Yeah, so right in here, we're right around 455, right in that neighborhood. And it looks great. It looks pretty stable. I don't see any jittering. At all. There may be some drift, but it's so small that my eye can't pick it up on the oscilloscope, which is fine. Now let's take a look at the power supply and see if we're generating noise through that. So here we are. I've set the probe to 10 times, 10x. So it's attenuating the signal that the probe reads by 10 times. And we're at a half a volt per division, so we're at around 9 volts. That's where we should be. Let's switch to AC now so we can zoom in on the clarity of that. And we're seeing some noise here too, some chopping coming from the switching power supply itself. So that's another source of noise that could be affecting the frequency counter itself. Not much noise though. Not much. 10. Let's see. Actually quite a bit. So that's 0.1 volts, so that's 100 millivolts. 250 millivolts of noise on there. Again, using the leads, the AC leads are not twisted, which they should be. Putting a shielded coax on the signal leads will help that as well, I suppose. But there is noise there, so we have to be aware of that. This little and tiny AC to DC converter is noisy because it's a switching power supply. So it has this switching noise going on all the time. But let's start with the coax, see how that treats us. All right, at this point I have, just for drill, twisted the AC line. Ultimately, when this gets installed, the AC line won't be this long going into the switching power supply. More interestingly, I've put this coaxial cable into a ground plane on the back of the primary oscillator board here, and also shortened the leads on the capacitor. You can see it right here, so it's hanging there. This is all now coax into the frequency counter. So let's see if this is. Make sure my wires are still. These are just tacked on, so I want to make sure they're still connected. So let's see. We're plugged in. Power. Oh yeah, look at that. Now we're getting the last two digits noise. So this coax is really important. It makes a huge difference Yeah, I can live with this. Oh, that's much better. Look at that. It's useful now. Yeah, check it out. 455 on the money with some drifting, small change. All right, that's good news. Okay, what I will do next, I'm satisfied with this. I think the voltage is fine. I think the noise coming out of the little switching power supply is minuscule enough. If it's affecting this at all, it's not enough that I care. I think this solution is working for me. So next is to start to finalize the assembly. And let me show you what I have in mind here. Pretty much following what X-Ray Tony B did on his. This little power supply, I wanted this piece of metal here, this metal plate, shields all the power supply stuff from the primary signal generator, oscillator circuitry. So this is very noise-free on this side. It can be noisy over here, and it's shielded by the steel plate. So what I'll do is mount. Let me unplug the AC connector. Come on. Okay. I will mount this on this side of the shielded stuff, and they've kindly drilled some holes here for a different piece of equipment. Don't know if you can see those. Get the light shifted around here. There. There's some holes right here I can use, but this doesn't have any mounting holes. It's so tiny. So what I'll end up doing, I think, is putting some Velcro tape on there and just Velcroing it right into there. And I'll shorten these wires appropriately so that they're just running from here to here. I'll cut all this off. Don't need all that. So that's where the power supply will be mounted. The power itself, since the frequency counter is being mounted outside the case, the power itself will come back to a power connector that will go in the back panel of the meter, of the signal generator rather. One of these guys right here. This will be mounted in the back panel, and then the frequency counter itself will connect. Oh, that's nice. Will connect. Will connect with one of these guys. So this will be mounted on the back panel, and then from here through this connector, you just plug the power in. So that anybody who gets this that doesn't like the frequency counter sitting up there can remove it. It'll just be Velcroed down to the case. They can unplug this. They'll have a 9-volt supply, and they'll also have a BNC connector for this cable. So this cable will come out to a BNC connector that'll sit on the back panel as well, and there'll be a short BNC cable that runs up to the frequency counter mounted on the top. So that's how it's going to be laid out. what I will do next is do all that, and I'll bring you back when I've got this part of it done. I'll show you what it looks like.
The makers of Johnson's Wax.